Okay, so today I'm just going to show you the difference between rectangular coordinates and polar coordinates. So for rectangular, it's your basic coordinate, like the example 2, 3. So if back, way back in algebra, back in 8th grade, remember your 8th grade self when you were learning algebra, you just plotted the point 2, 3, and there's just one way to do it, and that's what you did. So that's just very simple. It's unique because there's only one way to write it. The point 2, 3, that's it. There's just one way. Polar coordinates are not unique because there's several ways to express the same polar point. So one point can be written in several different ways. So the example is on page 492, and it is going to be number 24. They give the polar coordinate 1 negative pi over 4, and we need to write it in all forms, so all the different ways. So what I would do, since I like to be visual here, I'm going to write my plane, and then we get negative pi over 4, so you should know that pi over 4 is about right there, so negative pi over 4 is about right there. So I'm going to draw my line, and then let's make sure we go on the other side too. And then we have 1, so 1 would be right there. So obviously our first way to write it would be 1 negative pi over 4. Now this is going clockwise. This is the negative one. So what if I went counterclockwise? So what if I went this way, and I went around, and I went that way? This would be the same thing as 7 pi over 4. So we know from, I think this was like lesson or unit 4 or 5 or so, I don't remember which one, but we know that this is equal to this. So I think it was unit 5. So we know this is equal to this, so obviously we can write it both ways, and we have the same point. Okay, now what if we wanted to use this as a reference? So if we wanted to use this one, let's go counterclockwise. So this one's going to be across from 7 pi over 4. The one that's across from 7 pi over 4 is 3 pi over 4. And since now we're talking about this, we're talking about the opposite side, this is going to be negative 1. And then let's do that same thing, but let's go opposite. So let's go clockwise. And if we go this from here and we start clockwise, we go over 90, 180, and then we go over 2 spots, which is the same thing as negative 5 pi over 4. 5 pi over 4, and that will be also negative 1. Okay, so there's 4 different ways you can write the same exact point, but it all means that same point right there, that purple point. Okay, in the PDF that I posted yesterday, there is information on this. I'm not going to do it again because I don't know if I really liked writing on the little video. It was kind of hard to write on there. I rather would write in pen, so I'm just going to do it on here. But if you want to reference it, you can. But on there, you're going to have a slide that says how to change from a polar to a rectangular point. And all that is your x value is going to be equal to r cosine theta, and your y value is equal to r sine theta. Very, very simple. So I'm just going to show you number 18. And they give you the polar point, negative 2, negative 14 pi over 5. So we know that this is our r and this is our theta, right? So to find the x value, it's just negative 2 cosine of negative 14 pi over 5. And then the y value is negative 2 times the sine of negative 14 pi over 5. And then just plug that into your graphing calculator, and if you plug that in, you're going to get the point 1.6, 1.17. So this is your polar point, and we converted it into a rectangular point. And that's it. So for the assignment today, let me find what it is here. Okay, so it's on page 492. and it's numbers 15 through 22, not 18 because I just did that one, and then also number 23. So, and it's written on the module too in Canvas, but that's the assignment for today.